Hello everyone, welcome back to my channel Explain Maths. In this video, I am going to solve some of the extra questions from R.S. Aggarwal of the topic polynomials. So let's start with the first question. So question number 1 says that if alpha and beta are the zeros of the polynomial px, 2x square plus 5x plus k, satisfying the relation alpha square plus alpha beta equal to 21 by 4, then find the value of k. So here it is given alpha and beta are the zeros of the polynomial. Now we already know if there is a polynomial ax square plus bx plus c and alpha and beta are the zeros, then sum of the zeros alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. This we have already studied, right? So if you compare here, your a value is given as 2, your b is 5 and your c is k. So from here we can write sum of the zeros alpha plus beta, which is minus b by a, will be equal to minus 5 by 2. Because your b is 5 and your a is 2. Alpha beta, the product of the zeros will be c by a. Your c is k and a is 2. Now I am going to put this value in the relation which is given in the question. Alpha square plus beta square plus alpha beta is equal to 21 by 4. Isn't it? Now you have to find the value for alpha square plus beta square. Isn't it? Here you know the value only for alpha plus beta. You don't know the value for alpha square plus beta square. So what I can do? Alpha square plus beta square, I can write it as alpha plus beta whole square minus 2 alpha beta. We can check this value is same as alpha square plus beta square, because if you use the identity here alpha plus beta whole square, it will be alpha square plus 2 alpha beta plus beta square minus 2 alpha beta, and plus 2 alpha beta and minus 2 alpha beta will get cancelled and you are left with only alpha square plus beta square, right? So alpha square plus beta square, you are going to put the value here as alpha plus beta whole square minus 2 alpha beta. Okay, this value I have written only for this. Then plus alpha beta equal to 21 by 4. Again I am explaining how I have written. See, alpha square plus beta square, just now I have explained here. This is same as alpha plus beta whole square minus 2 alpha beta. So in place of alpha square plus beta square, I have substituted this alpha plus beta whole square minus 2 alpha beta. And then plus alpha beta I have written as it is, and this complete is equal to 21 by 4. Now next, alpha plus beta whole square will remain as it is, and minus 2 alpha beta plus alpha beta will become minus alpha beta equal to 21 by 4. We already know the value of alpha plus beta, isn't it? Already we know alpha plus beta is minus 5 by 2 and alpha beta is k by 2. Now I am going to put those values over here. So alpha plus beta whole square will become minus 5 by 2 whole square minus k by 2 equal to 21 by 4. Right? Now minus 5 by 2 whole square will be 25 by 4. Isn't it? This is 25 by 4, and then I am transposing 21 by 4 to LHS. So minus 21 by 4 equal to k by 2. Now 25 minus 21 is 4 by 4 equal to k by 2. So from here we will get the value of k by 2 is equal to 1. So k will be equal to 1 into 2, which will give me 2 as the answer. Okay. So the value of k is 2. I hope it is clear to everyone. Now I will solve the next question. Question number 2. If x plus 1 is a factor of the polynomial given here, then find the value of a. So here x plus a is a factor of this polynomial. It means when you put the value of x as minus a in this polynomial, the value will become 0. Isn't it? We have already studied this type in grade 9 chapter polynomials. So just try to recall. If I take let fx equal to 2x square plus 2ax plus 5x plus 10 and x plus a is a factor, then it means if you put x plus a equal to 0, you will get x equal to minus a, isn't it? It means if you put the value of x as minus a in fx, what will happen? The polynomial will be 0. It means x equal to minus a is the 0 of the polynomial. So f of minus a should be 0. Okay, we already studied this in grade 9. So since x minus a is a factor of f of x, then f of minus a will be equal to 0. Now let's put the value of x as minus a in the given polynomial. So it will be 2 into minus a whole square plus 2a into minus a plus 5 into minus a plus 10 equal to 0. Now it will be 2a square minus 2a square. See, minus a whole square is a square, and here also a into a is a square, and this minus and plus will become minus. Minus 5a plus 10 equal to 0. Now 2a square and minus 2a square is 0. So you are left with minus 5a plus 10 equal to 0. Now I am transposing 5a to other side. So 10 is equal to 5a, and the value of a will be 10 by 5, which is equal to 2. So the value of a is 2. Now question number 3. If 2 by 3 and minus 3 are the zeros of the quadratic polynomial ax square plus 7x plus b, then find the value of a and b. So here zeros of the polynomial are given and you have to find the value of a and b. So let's find first sum of the zeros of the given polynomial. So sum of the zeros will be minus 2 by 3 plus minus 3. Sum of the zeros. As zeros are 2 by 3 and minus 3, so you have to just add it. Okay, now take the LCM. So LCM is going to be 3. So it will be 2 plus minus 9, which will give me minus 7 by 3. And what will be the product of zeros? Product of the zeros will be equal to 2 by 3 into minus 3, which will give me, see, 3 and 3 cancel, I will get minus 2. Now we know that product of the zeros is also c by a equal to minus 2. Now from where I am writing c by a, if you try to recall, if the polynomial is ax square plus bx plus c and alpha and beta are the root, then alpha plus beta, the sum of the zeros is minus b by a and the product of zeros are c by a. So product of 0, which I got here, minus 2, that is equal to c by a. Now if we compare this, a is a only, b is 7 and your c is b. So let's put all the values. So c will be b by a equal to minus 2, and if you cross multiply, b is equal to minus 2a. This is from product of the 0. Now sum of the zeros we got as minus 7 by 3, right? And what is sum of zeros? Minus b by a equal to minus 7 by 3. Let's put the value of minus b and a. So b is 7. So minus 7 by a equal to minus 7 by 3. Now cross multiply. So minus 7a equal to minus 21. From here I will get the value of a as minus 21 divided by minus 7, which will give me a as 3. And we already know that b equal to minus 2a, isn't it? Here only we have found. Now put the value of a here. So minus 2 into 3, which will give me minus 6. So the value of a is 3 and the value of b is minus 6. So these are the values of a and b. So again I am explaining what I did. Already the zeros of the polynomial was given. So first I found the sum of the zeros by adding this. Then I found the product of the zeros by multiplying it. Now we already know that if alpha and beta are the zeros of the polynomial, then sum is equal to minus b by a and product is c by a. Now I'm using this relation and putting it over here. Product is c by a, and if we compare this general polynomial with this, the given polynomial, you can see here your c is b and your a is a only. So c by a is minus 2. Okay. So in place of c, you have to put b. So b by a is minus 2. And if you cross multiply, you are going to get a relation between b and a. Next, Sum is minus b by a and b is 7. So minus 7 by a is equal to minus 7 by 3. And cross multiply, so a into minus 7 is minus 7a, minus 7 into 3 is minus 21, and the value of a is 3. And then put this value of a over here and you will get the value of b as minus 6. So this is only your values of a and b. Now moving to next question. If the product of the zeros of the polynomial ax square minus 6x minus 6 is 4, then find the value of a. So here only the product of the zeros are given over here. And we know that product of the zeros is, what is the relation? It is constant term by coefficient of x square, or you can say c by a. Here if you compare with the normal general polynomial, your a is a here, your b is minus 6 and your c is also minus 6. Okay, b is also minus 6 and c is also minus 6. And what is product of the 0? C by a means minus 6 by a. This is your product of the 0. Now using this relation only you have to find the value of a. So I've assumed that alpha and beta are the zeros of the polynomial ax square minus 6x minus 6. So product of the zeros, it means alpha beta will be equal to c by a, isn't it? And what is your c here? Minus 6 by a. And this value is given as, product of the zeros is given as 4. So 4 is equal to minus 6 by a. Now do the cross multiplication. So 4a equal to minus 6 and the value of a will be minus 6 divided by 4. Simplify, 2 2s are 4, 2 3s are 6. So the value of a is minus 3 by 2. Now moving to next question. Since it is given in the question number 5, if one zero of the polynomial is the reciprocal of other, find the value of a. So first of all, if you compare this with the general polynomial, which is in the form of ax square plus bx plus c, this is your a, this is b, and this is your c, right? And what it is given, 1 0 is the reciprocal of other. So I have assumed let the first 1 0 is alpha. So another 0 will be reciprocal of alpha, which is 1 by alpha, right? And then if I have to find the product of the 0, then we know that product of the 0 is constant term by the coefficient of x square, or we can say it is c by a, which is equal to 6a by a square plus 9. And already I know I have taken my zeros as alpha and 1 by alpha. So their product will be alpha into 1 by alpha equal to 6a by a square plus 9. Now alpha and alpha cancel. Cross multiply. So a square plus 9 is equal to 6a. Now transpose 6a to LHS. So a square minus 6a plus 9 equal to 0. And a square minus 6a plus 9, if you see, 9 is a square of 3, isn't it? And you can write 6a in the form of 2ab. 2 into 3 into a plus 3 square equal to 0. So it is a minus 3 whole square equal to 0, which will give the value of a as 3. So from here I got the value of a as 3. So I hope it is clear. Now these questions are almost similar. There you have to just use some of the zeros and product of the zeros and you have to solve it. So when I'm solving the next question, if you already know how to solve the question, please pause the video and solve it by yourself. Now moving to question number 6. Now question number 6. If alpha and beta are the zeros of the quadratic polynomial fx equal to x square minus 4x plus 3, then find the value of alpha to the power 4 beta square plus alpha square beta 4. So first of all, let me compare this given polynomial with the general polynomial. Isn't it? My general polynomial is ax square plus bx plus c. If I compare here, my a is 1, okay, b is minus 4 and c is 3, isn't it? And it is given alpha and beta are the zeros of the polynomial. So let's find the sum of the zeros. Alpha plus beta is equal to minus b by a. So it is minus of minus 4 by 1, which will give me the value as 4. And alpha beta is c by a, which is 3 by 1 equal to 3. So I got the value of alpha plus beta. I got the value of alpha beta. Now what I have to find? I have to find the value of alpha to the power 4 beta square plus alpha square beta 4. From here I can take alpha square beta square common. So I will be left with alpha square plus beta square. Isn't it? Here alpha to the power 4 is there. Square I have already taken out. So again alpha square is left. Same way here beta square is left. Now alpha square beta square. Alpha square plus beta square already I have done in the beginning of one of the question. Alpha square plus beta square is same as alpha plus beta whole square minus 2 alpha beta. Okay, you can again go to the previous question and there I have solved this one. Okay, alpha square plus beta square is same as alpha plus beta whole square minus 2 alpha beta. Now next step is you have to substitute all the values. So alpha square beta square means alpha beta whole square. This is alpha beta whole square. So 3 square, because product of alpha and beta is 3 and alpha plus beta is given as 4. So alpha plus beta square means 4 square minus 2 into 3. So 3 square is 9, 4 square is 16, 16 minus 6. So this will give me the value as 9 into 10, which will be 90. Okay. So the value of alpha to the power 4 beta square plus alpha square beta 4 is 90. Question number 7. Find the value of k such that the polynomial this had sum of its zeros equal to half of their product. Okay, this is the relation. Sum of its zeros is equal to half of their product. So if I assume my alpha and beta are the zeros of the polynomial, it means what this relation says, sum of the zeros. Zeros are alpha and beta. It means alpha plus beta is equal to half of their product. Product is alpha beta. Now this is the relation given over here and using this relation we have to find the value of k. So first let's find the value of alpha plus beta, which is equal to minus b by a. Now again your a is equal to 1. This complete is your b and this is your c. So alpha plus beta is minus b by a. It means minus of minus k plus 6 by 1, which will give you k plus 6. So this is your alpha plus beta value. Now alpha beta is c by a. Your c is 2 whole 2k minus 1 by a. A is 1. So it is 2 whole 2k minus 1. Now what is the relation given according to the question? Alpha plus beta is equal to half of alpha beta. Let's put the value. Alpha plus beta is k plus 6, which is equal to half of 2 into 2k minus 1. 2 cancel. So k plus 6 is equal to 2k minus 1. Now I'm transposing minus 1 from RHS to LHS. It will become 6 plus 1. And I'm transposing k from LHS to RHS. So 6 plus 1, 7 equal to k. 2k minus k is k. So the value of k is 7. Okay, so hope it is clear to everyone. Now moving to question number 8. Now question number 8. If alpha and beta are the zeros of the polynomial fx equal to x square minus 5x plus k such that alpha minus beta equal to 1, find the value of k. So polynomial is given and it is also given that alpha and beta are the zeros of the polynomial. So first let's find the sum of the zeros and the product of the zeros. So alpha plus beta equal to minus b by a, and if you compare here your a is 1, b is minus 5 and your c is k. So minus b by a means minus of minus 5 by 1, which will give you 5, and alpha beta is c by a, which will give you k by 1 as k. Now one relation is given, alpha minus beta is 1. Now I'm going to square on both the sides. Alpha minus beta square whole square equal to 1 square. So alpha minus beta whole square I can write as alpha square plus beta square minus 2 alpha beta equal to 1. Now alpha square plus beta square, already we have seen that we can write it as alpha plus beta whole square minus 2 alpha beta, isn't it? This value is alpha square plus beta square. Then minus 2 alpha beta equal to 1. Now let's put all the values over here. First let me open the bracket. So alpha plus beta whole square minus 2 alpha beta and minus 2 alpha beta. It will become minus 4 alpha beta equal to 1. So alpha plus beta value is 5 square minus 4k equal to 1. So 5 square is 25 minus 4k is equal to 1. Transpose 1 from RHS to LHS. 25 minus 1 equal to 4k. So 24 equal to 4k. So the value of k will be 24 by 4, which will give me a value of k as 6. So k is equal to 6 as the answer. Okay. So you can see that in many places I have used this alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. So you should always remember this relation, how to find out alpha square plus beta square using sum of the 0 and the product of the 0. Okay, because in many questions we are using it. And the question which I'm solving now, most of the questions have already come in the previous board questions. Okay. So now moving to question number 9. If question number 9, if alpha and beta are the zeros of the polynomial this, then find the value of alpha by beta plus beta by alpha. Now if you compare this with the general polynomial, your a value is 6, b value is 1 and c value is minus 2. Let's find alpha plus beta, which is equal to minus b by a, which is equal to minus 1 by 6. Alpha beta is c by a. So your c is minus 2, a is 6. And if you reduce it, you will get minus 1 by 3. And what you have to find? Alpha by beta plus beta by alpha value. So first take the LCM. So LCM is alpha beta. So this will be alpha square plus beta square. Again see, it is alpha square plus beta square. So we can write it as alpha plus beta whole square minus 2 alpha beta divided by alpha beta. Now let's put all the values. So alpha plus beta is minus 1 by 6 whole square. Then minus 2 into minus 1 by 3 divided by minus 1 by 3. Next, minus 1 by 6 whole square is going to give you 1 by 36. Then minus and minus plus 2 by 3. And as it is in the form of fraction, I am going to write it as in this form, isn't it? This division is same as this division. So I'm replacing it because it is easy to do it. I'm taking 36 as the LCM over here. So it will be 1 plus 24 divided by minus 1 by 3, which will give me 25. 1 plus 24 is 25 by 36. Division change to multiplication and reciprocal of minus 1 by 3 is minus 3 by 1. Now reduce it. So the answer is minus 25 by 12. Okay. So the value of alpha by beta plus beta by alpha is minus 25 by 12. Now moving to question number 10. Now question number 10. If alpha and beta are the zeros of the polynomial fx equal to 5x square minus 7x plus 1, find the value of 1 by alpha plus 1 by beta. So again, if you compare this with the general quadratic polynomial ax square plus bx plus c, so your a is 5, b is minus 7 and c is 1. Okay. First of all, we will find alpha plus beta, which is minus b by a. So you'll get the value as 7 by 5. Alpha beta is c by a, which will give you the value as 1 by 5. And what you have to find? You have to find the value of 1 by alpha plus 1 by beta. Let's take the LCM. Alpha beta is the LCM, then it will be beta plus alpha. And beta plus alpha is given as 7 by 5 whole divided by 1 by 5. Now see, whenever you see the question is in fraction, okay, better you write in this division form. It will be easy for you to do the calculation. Now 7 by 5 division change to multiplication, 5 by 1. So the answer is 7. See, this division line I have changed here. Okay, so like this it is quite easy to solve these type of questions. So I hope it is clear now to everybody like how to solve these type of questions. These are not very tough question and easily you can score marks in your exam. Okay, so that's all for today's class. If you like my content, please subscribe to my channel and share with your friends also. Thank you. See you in the next class.